Yeah. Hi, everyone. Thank you so much for joining in after lunch. This is track 2, and we would be starting with the first speaker post-lunch. I'd like to call upon Esteban, who will be sharing his insights on building trust in every artifacts with SBOM. So Esteban, stage is yours.
Hello, everyone. How's everyone doing? Was lunch okay? Yeah? Hope that you don't get to fall asleep during my talk after lunch. So yeah, like the slide says, my name is Esteban Garcia. I'm a principal engineer at Cloudsmith, the cloud-native artifact management solution. And I'm here today to talk about SBOMs. And the talk is going to start from the very basic levels of SBOMs. So if you don't know anything about them, then you are in the right place. If you know a lot about SBOMs, I'm hoping that you can actually take something out of the talk as well. I'm catering here for all levels, so welcome. We're going to be going through best practices on how to generate and store SBOMs and can you actually use the SBOMs for something useful and not just have a JSON document lying around somewhere. So what is an SBOM? If you don't know what an SBOM is sort of like a list of ingredients that make up your software, right? And it tells you everything. If you have a container images, for example, it tells you everything that composes that container image, not only the software that you're deploying as part of that container image, but also any other OS packages that are inside of that, including licensing, versions, and even dependencies between each other. And basically, it all reduces to try to answer this question within your organization. By having an SBOM, you can actually answer, are we running any software with, I don't know, a non-permissive license in our enterprise? Or are we running any software that has this particular vulnerability in this component that has just released 2 days ago? This is basically what you want out of an SBOM, be able to answer this question. And there are other benefits around that as well. You can use SBOMs for vulnerability management. You can actually use tools like Trivy, for example, to give the SBOM to Trivy, and it's going to tell you all of the different vulnerabilities, if there are any, that that particular piece of software that you are deploying has. It also allows you to build trust with users, gives transparency on your software supply chain, because it has that complete inventory list of everything that is being deployed as part of your container image or software. Your users can actually see what you are deploying as part of that. And this third part, I think, is one of the most interesting parts from a regulatory standard. It allows you to actually help you meet regulatory standards if there are any in your company. There are 2 formats being used in SBOMs right now. I'm pretty sure that in the future we'll see more of them, but right now you either going to be using SPDX or CycloneDX. SPDX it's the first format that started all of this, and it has a more of like a licensing angle. If you are more interested in knowing licensing of your software, especially around regulatory standards, SPDX is what you want to use. If you're more focused on vulnerabilities, mostly CycloneDX has that that focus more like that. And talking about regulatory compliance, I want to go through this slide quickly because no one actually wants to talk about this ever. But Executive Order 14028 that was mandated in 2021 by the US government is what basically started driving SBOMs massively. Basically because it said that if you are a vendor and you want to sell software to the federal government of the United States of America, then you must have SBOMs in all of the software they have. So this started driving a lot of the usage for SBOMs. That was then expanded by CISA 2025 by actually saying that you don't only need to have SBOMs, but also now you need to have this minimum elements as part of your SBOMs, like licensing, components, and versions. It's not only just the name. And finally, EU Cyber Resiliency Act, it's quite a mouthful. If you are in the EU, this is not something that's only US-based. The EU has something very similar, which is that, the EU CRA. And it's then again, a set of security standards that we follow in the EU for the same thing. So this is why you want an SBOM in your company, right? But it goes beyond just being able to sell software to a public government or entity. Thanks to this and to the executive order that started everything, private companies are following the same, and the commercial world is following this same set of standards. So how does an SBOM look like? Usually people don't actually get to see the JSON behind scenes. They just generate the SBOM and then they run the SBOM through different pieces of open source software. But this is how it roughly looks like. This is a very small example of an SBOM. It usually takes the form of an XML document or a JSON document. And the first thing that you will see is the format that the SBOM is using. In this case, CycloneDX specification version 1.5. The next part is metadata about the SBOM, specifically provenance, freshness, what tooling was used to generate the SBOM document, and also what is the SBOM describing. So if in this case, you will see that it says type container, has a name and a version. So that means that this SBOM is describing a container image of the name my app and version 123. And the next part is the meaty part, right? That list of ingredients, which is actually what you want out of the SBOM, which is everything that it is inside this container image. In this particular example, you will see that we have two components. One is a OS package, which is OpenSSL. The other one is actually a library out of the application that we are deploying as part of this container image. Hey, how's it going? Take a seat. And it describes identity, integrity, licensing, and different relationships in between those components. Around integrity, now this particular example doesn't have it because it's completely optional, but you might see cryptographic hashes as part of those components, and you can use those hashes to actually determine if there has been any component that has been tampered with since this SBOM was created until that container image was deployed on your infrastructure. And it also contains, as you see, licensing, which is something that you can use to actually know, is my company running any software with non-permissive licensing, like GPL-free, for example? No one wants to use that. You can get that information out of the SBOM. Okay, so now I've established this sort of like roadmap to walk through you around how you can actually create a CI/CD workflow in your company to go through SBOM generation all the way to actually using the SBOM at the end as part of the CI/CD pipeline, sorry. And we're going to go through all of these four as part of this presentation, starting with SBOM generation. Now, SBOM generation, the best practice around this is that it should be integrated directly into your CI pipeline. If you are building a container image or if you are building software, you want to generate that SBOM as well as part of your CI pipeline. You don't want to do it as an afterthought. If there is any time gap in between the moment that you built your software or container image and the moment that you created that SBOM, it leads into question if that SBOM is valid or not, and if the software that was deployed is actually meeting that SBOM compliance. And this is a very brief example. This is specifically a GitHub Actions workflow here for generating an SBOM. You'll see that the first step is building an image. As in a real pipeline, you'll have more steps before this of actually getting your code and probably building it and then packaging it with your Docker. And this is just stream for example purposes. This particular pipeline is using Trivy, which is an open source tool developed by Aqua Security. And this Trivy gives you different things that you can do. I think the most popular one is actually scanning containers or scanning SBOMs for vulnerabilities. But you can also generate an SBOM using Trivy as well. So this is building your Docker image. Then the last step is calling Trivy, passing in that Docker image to generate that SBOM, and giving the name of the output where you want to actually put that SBOM somewhere. And how does this work? Actually, Trivy gets your container image, and it's going to unpack all of the layers, and it's going to recreate that file system, and then it's going to be scanning all the file system of the container, looking for specific hints around what type of software you are deploying here. If it's NPM, if it's Go, it's going to go look for those hints to know what that is, and it's going to then get the information. If it's NPM, it's going to go look for the package JSON and package log JSON files, and that's where we're going to get its component list from. And then for the OS packages, for example, it's going to go take a look at the hints that actually tells it what type of OS you're running on. So if it's Ubuntu, it's going to go look at the pkg folders to actually get all of the packages that are installed, and it's going to put all other information in the SBOM. That's a very rough idea. So yeah. So key takeaways around this. So always generate your SBOM as part of the build, not as an afterthought, as I said. So retrofitting SBOMs, they create confusion. And that time gap is going to lead to questions about authenticity and accuracy. especially if you have to follow those regulatory standards for selling software to the federal government, or even if you have companies that actually require you to follow those standards. And specifically in the EU and in the CURA regulatory standard, it actually calls out specifically that SBOMs must be generated as part of the build process or something similar. Something similar could be some registries, for example, allow you to create that SBOM when you push your container image to the registry directly. So if you're using Harbor, for example, Harbor can do that. And if you're using Cloudsmith, Cloudsmith can do that as well. And also always update your SBOM. So every time that you create a new version of your container image or software, create a new SBOM. It's not a one-time thing. It's not like I create the SBOM once and I don't do it ever again. Software evolves, dependencies change. So always keep up to date with your SBOMs. So let's talk a bit about SBOM storage now. So we created the SBOM, but we actually didn't put it anywhere. It just died as part of that CI pipeline there. I think one of the best things that you can do with this, and this is thanks to the OCI v11 specification. So if you don't know OCI v11 specification, it actually formalizes being able to store any sort of artifact on OCI registries, whatever you want, not just container images. That was something that you could do before OCI v11. There were ways around it, but with OCI v11, it was actually formalized. It was formalized by adding 3 things to the OCI distribution specification. The first one is OCI artifacts can have an optional artifact type, so it's not only a container image anymore. It can be anything that you define that makes sense for you in your organization or software. So if it's an SBOM, you can add, I don't know, application/vnd.sbom v1, for example. That defines what that generic artifact that you're pushing to a registry is. The next thing is subject. The subject is a way, as specified in the specification, for you to actually create relationships in between artifacts. The way that this was done before OCI v11, and was actually created by Cosign, when you pushed a container image and then you wanted to create a relationship with another container image that was pushed, Cosign what did was it created a tag for that second artifact that was equal to the digest of the first one. And that is the way that it created relationships, one to the other one. But tags, they're not immutable. They can change, so that's sometimes not great. But in OCI v11, by adding this new field, you can actually say, this artifact that I'm pushing here is related to this one here, and you can create those relationships on the registry. And with those relationships, you can actually use the third new feature added here, which is the referrers API, which allows you to say, I have this OCI artifact here. Give me all of the dependencies or relationships that this particular image has here, so you can discover things like SBOMs or even other stuff that you want. You can literally do whatever you want. And specifically for SBOMs, this is great, because this means that if you push SBOMs using this to your OCI registry, you basically are cryptographically tying that new generic artifact that contains your SBOM to the image that it's actually describing. And you can do this by using CNCF tooling or even developing your own. In this example here, I'm using ORAS. So if you don't know ORAS, ORAS stands for OCI Registry as Storage. It's a CLI that allows you to push anything you want to an OCI registry. Not only container images, you can store your photos if you want. In this particular example, I slightly modified that GitHub Actions workflow to say, okay, after I generate the SBOM, now using the ORAS attach command, push that SBOM as a generic artifact, and also create a relationship in between this generic artifact that you're pushing to my registry with the image that is actually describing the SBOM. That ORAS attach command is going to do both. So it's taking that SBOM JSON file that is describing there on the last line, it's creating that OCI generic artifact, is pushing it to the registry, and it's also creating that relationship using that subject field that I spoke about earlier. And if you see there on the first line after ORAS attach, it says artifact type. So this is setting the generic artifact type as application/VND CycloneDX. Now, this is something I created that is not like a standard out there for that artifact type, but this is the power of OCI v11 specification. Then using ORAS, you can just run the ORAS discover command, pass in that image that you want to know what artifacts has relationships with, and you can get everything. And in this case, I see, hey, this one has an SBOM there. So always co-locate SBOMs with images. This is a best practice. Doesn't mean that you have to follow it for any regulatory standards. This is something that I recommend you doing. If your SBOM travels with your artifact automatically, it has that immutable binding, and it's way easier for you to actually manage. And also standardize the attachment, right? There is plenty of CNCF tooling out there that you can use for this. It's not only ORAS. Actually, we're going to be looking at cosign in 1 second about this. But this makes sure that when you push your SBOM to an OCI registry, it's going to work across all of compliant registries, not just the one that you're using. Okay, let's talk a bit about attestations. I show you how to generate an SBOM, how to push it and store it somewhere. But how do you actually know that that SBOM has not been touched or tampered with, right? At the end of the day, it's just a JSON document. Anyone with access can go in, either on purpose or not, change it, and you would never know about it. So an attestation is cryptographic evidence that that SBOM has not been tampered with. And you can use cosign, which is the tool that I mentioned just now, to actually get that SBOM, sign it, and then you, in the same way as I showed before, you store it on your OCI registry. And then when you go and you use your container image, you can get that SBOM as well, and you can verify that attestation. You can verify that signature. That is basically creating a way for you to know that that has not been tampered with. It gives you more security around that. It transforms your SBOM from a static document into an actual verifiable claim. And, okay, yes, before the workflow. So what is the attestation? How does it work? In Toto is one of the frameworks for actually creating these cryptographic attestations. And it basically creates that link, that evidence to the software artifact that you are defining. And like I said, an attestation is basically a cryptographically signed and linked document to a specific image digest. And the way that it works is by using DSEE, which is the easy way of creating what's called a security envelope. And in Toto, it's going to get that SBOM that you created, and it's going to wrap that around, it's going to envelope it, and then it's going to sign that envelope. And as part of that envelope, it's going to include things like metadata about the predicate, the subject, and also who signed it. And all that information is what you're going to then be using for verifying that signature. One thing is, well, you can use cosign as I mentioned for doing this. It is very easy, it's one command. And one cool thing, at least for me, cosign supports keyless signing, so you don't actually need to even manage keys if you don't want to. You can just use OIDC to sign your SBOMs. So if you have a OIDC provider within your own enterprise, you can just use that. You don't need to manage keys manually, which I think is a pretty good value. So in this example, I modified that same previous workflow that I showed before, but now instead of using ORAS for attaching and pushing that SBOM to the registry, I'm actually using cosign. So cosign has a similar feature there. So if you use the cosign attest command, that is going to do the two things for you. It's going to get the SBOM, it's going to create that attestation, that signature on the SBOM. It's going to create also the relationship with the OCI artifact, and it's going to push it to the registry all in one go. And it's literally just down one line. It's very easy. One thing to note here, you will notice last line of this workflow, there is an environment variable named cosign experimental, and that is set to 1. Now, OCI v11, it's actually not new, but it's not old either. There's a lot of tooling that has not catch up with that specification yet. Cosign is almost there, but it is behind the feature flag, so you need to set that cosign experimental environment variable. And with some commands, there is a flag as well that is -- experimental OCI 11. You need to set that to true. If you don't do that, then OCI 11 is not going to be used, and the previous way of pushing generic artifacts is going to be used. But if you do it like this, then again, you can use ORAS again to discover artifacts that are linked to your container image. And in this case, here I push the attestation there to the registry, and it's showing the artifact type that Sigstore uses for these signatures. But now you can also use cosign to do the exact same thing. You don't need to use ORAS anymore if you don't want it. Cosign has a similar command called tree. And as long as you pass that command that I said before, experimental OCI 11, you'll be able to actually get the same information. So, key takeaways here. Attestations, cryptographic proof of your SBOMs transforms your SBOMs from a static document into something that you can verify. The signature proves that the SBOM has not been tampered with. Always sign at build time. There's no reason to not do it. You have all of the information as part of the pipeline that is generating your SBOM. There's no need to actually do it after. If you do it after, then again, you have that question in your mind of, has this SBOM been tampered with? Because it has been created by a separate process and not at the same time as your build happened. That is going to create that immutable record for your SBOM. And with this, this starts to enabling you and your organization in showing your supply chain provenance. Attestations, they create a verifiable chain linking the SBOM to who built it, who signed it, the identity, and the timestamp. And this starts to satisfy compliance requirements from SALSA and EU CRA, and also what I showed before about the US federal government. Validation. So now you have an SBOM, what can you do with it, right? It's amazing to have it. You are complying with stuff, but where is the value coming from beyond just meeting that standard? So the validation here is going to act as a quality gate when you deploy your software to whatever it is that you deploy it. Before an artifact is deployed, you can actually get that SBOM, get that attestation, you can verify it, and you can actually do some quick analysis before that software actually hits your, let's say, Kubernetes cluster. You can use things like admission controllers in Kubernetes, even OPA if you want, to actually enforce policies within your organization. What those policies are, well, depends a bit on your security guidelines within your enterprise, but let's say that you don't want to run any software with GPL-free licensing. You can use RICO policies here, for example, to actually achieve that. But let's actually split validation into two parts here. Let's actually split it into verifying the attestation first, and then actually running a policy or verifying your SBOM. And I'm saying let's split the two because they serve slightly different purposes. So when you get your SBOM that has the attestation, the first thing that you should be doing is validating that cryptographic proof that you created before to know that that SBOM has not been tampered with. Like I said, attestations, they prove who created the SBOM, and validation policies, which is something that should come after verifying the attestation, actually proves what is in the SBOM and that is meeting your licensing requirements or other requirements in your organization. And you can actually do both things at the Kubernetes admission level if you want, before your images are actually deployed. Some registries actually allow you to do policy enforcement to reject images without valid SBOMs or attestations, even before downloading the container image at all. I think Harvard allows you to do this. Cloudsmith also allows you to do this. And also, when you have the SBOM and when a new vulnerability is discovered, you can actually validate across all of your organization if that vulnerability actually affects you or not. If you have that SBOM, then you can do everything simultaneously without actually having to download the container image, because if they are very big, your image is going to take quite a while to actually download and analyze. And in fact, with the SBOM, it's much, much quicker. You can lean on tooling that is available out there to do this stuff. Like I said, with Cosign, you can verify your attestation very quickly, and you can use Trivy or even Syft or Grype to do vulnerability scanning on the SBOM. So this is how it looks like, verifying an attestation with Cosign. It was one line to create one. It is then again one line to verify one as well. Then again, always passing that experimental OCI 1.1 if you want to use OCI v1.1 as a standard. So this command sets what type of SBOM you're verifying. If you don't set the type correctly, verification will fail. That is part of the signature. And in this particular example, when I created the attestation, I did keyless signing. So you need to pass in the issuer of the token and the identity of the certificate used to sign that attestation. In this case, I use GitHub. Well, that is a fake email, of course. And you specify which image you want to verify that attestation. If you notice, I am not actually passing in the artifact of the SBOM. I am saying, please verify this image. And Cosign is going to automatically go to the OCI registry, and it's going to look for the SBOM thanks to that link that has been created in the registry using that subject field. And it's going to get the attestation, It's going to download it, and it's going to validate that, that signature. And after that, if everything is fine, it's going to return back to you the attestation document there. What can you do with that attestation document after it has been verified? You can redirect this to a file, and then you can tell to Trivy, I have an SBOM here, please analyze it for me. And Trivy is going to create a report for you with all of the vulnerabilities that are affecting that particular container image. And all of this was done without downloading the container image, just that JSON document. And in this case, Trivy is saying, okay, this is a Go binary application, has 21 vulnerabilities, 13 medium, 8 high, 0 critical. Now with this information, you can go back and you can actually, it will give you more information. This is just trimmed for this screenshot, but it's gonna allow you to say, okay, I'm gonna check all the vulnerabilities, see if there's anything that actually affects me, and you can go and fix them. Ideally, you're gonna be doing this constantly, not just once. You want that SBOM to be analyzed constantly because there's new vulnerabilities happening all the time. If you're using Kubernetes, like I said, you can use an admission controller, and I think the easiest way is to use Sigstore's policy controller for this. You deploy that, and it allows you to create a cluster image policy that is going to check all of your images deployed across all your cluster that fits that glob that is created there. In this case, this is, okay, please analyze or actually verify all of the images that had been pushed to that registry, and you pass in what was used to sign the attestation, and at the end, you pass in what's called a predicate, which is, I am going to be verifying that this SBOM is a CycloneDX SBOM. There's one caveat, OCI v11 is not yet supported on this controller. There's actually a pull request open, that QR brings you there, so if you want to use OCI 11, wait for that to be merged. If you use OPA Gatekeeper, unfortunately OPA Gatekeeper doesn't support getting SBOM information and attestation information into policies. I created a provider. Gatekeeper supports something called external data. It allows you to get external data and putting into policies so you can analyze them. I created a provider for that. This is an example of the YAML that you can use with that provider. You can say, I don't want these licenses, and there is a REGO policy that is going to get that information, and it's going to either allow you or deny that. I do not recommend that you use what I created in your enterprise. This is just a proof of concept, but you can use this to actually create something on your company. This is, unfortunately, it's not batteries included, Gatekeeper, so you need to do your own stuff with it. So how do we actually achieve this at Cloudsmith? So I mentioned before that some registries actually help you with this a bit. In Cloudsmith, if you push a container image, we create an SBOM automatically, and then using our enterprise policy manager, you can create a very simple REGO policy like this one. It's literally 3 lines. It checks that all of your packages are using those licenses, and if they're not, they won't allow them to be downloaded. So key takeaways here, attestation verification is not the same as SBOM validation. So you want to verify both, one for tampering, the other one for regulatory standards as part of your policies. Always validate at admission time. If you already deploy your software, you are already running a trusted code, so don't do it after, do it before. And rely on tooling, right? CNCF has great tooling for all of this. There's no need to create your own except for maybe OPA Gatekeeper. But just use the tooling that is available. So using SBOMs in incident response, compliance, and auditing. So if your manager asks you, why the hell do I need to spend time on SBOMs, you say this to them, okay? And this is a real life example, and it was very coincidental. This happened 2 days ago. When there is a high severity CVE, in Cloudsmith we create an internal incident, and we check how is this affecting our customers and what can we do about it. This is not something that we show publicly ever. In this case, the React Native CLI had a pretty high severity CVE that was found a couple of days ago. And because we create all SBOMs on everything that is pushed to Cloudsmith, it is very easy for us to go and simultaneously check all SBOMs for all of our customers and actually let them know that they are affected on this. So we found 1,200 packages that were affecting 13 customers, and we notified every single customer, and we gave them examples of policies that they could apply at their organization level, or even if they wanted us to apply those policies for them. And we went from literally declaring an incident to actually notifying everyone in less than an hour. This QR code here will take you to a README file in a repository, has a lot of supporting documentation and all of the links that are part of this presentation, even this presentation as well. You can go get everything there. Right. Thank you so much.
Yeah, we'll go. We'll take a couple of questions.
So for container images that, let's say if I get a container image from a vendor, right? And that contains like, it's a scratch image, gives me a Go binary inside it, right?
Yeah.
What value does SBOM provide besides license, other than just licenses in that case?
It's not only license, so maybe you won't have any OS packages installed in the image, but your application is still gonna be there, and your application has dependencies, and all of those dependencies are gonna be listed.
Even for binaries?
Even for binaries, yes.
Okay, thanks.
So the whole build attestation pipeline is great for internal use, but one of the purposes of an SBOM is supposed to be so that I, as a downstream consumer, can tell what you, as my upstream vendor, put into your stuff.
Yep.
What stops you from just lying about that and then signing that lie and then sending it downstream to me, and I think everything's cool, and actually there's 6 times as much stuff in there as what you told me is in there?
Yeah, I actually didn't include this in the presentation because, as you can see, I barely did the 30 minutes, but there's something called a transparency log. So go look at that. Google for recourse transparency log. When you sign your attestations using GoSign, that is automatically going to create a log in that public transparency log. That the public key use is going to be available there, and also who signed it, and the attestation is going to be available publicly, and you can actually take a look at that log to know that it has not been tampered with.
So this is basically like a flight data recorder for your build process?
Yes, basically. But that is public. If you are running only private software, then you need to have something similar privately. The Recore API is public, so you can create something similar for that.
Great, thank you. Do we have any more? We could take one more question.
I'm going to be around as well, so if you want to have a chat, just find me.
Okay, cool, yeah. He'll be around. Thank you so much.
Yeah, no worries. Thank you.
He'll be around. You can catch him up.